Hello everyone, I'm Aaron from Petabridge, and today I wanted to talk a bit about OpenTelemetry in .NET, which is going to be the future of observability for all .NET applications going forward. Now, we normally talk a lot about Akka.NET and building distributed systems on this channel, but OpenTelemetry is something that's a much bigger in scope than that, and we wanted to go ahead and kind of address conceptually what it is, why it's important, and why it's something you should care about if you're building production applications in .NET. So prior to OpenTelemetry, what the state of the APM ecosystem kind of looked like. And APM is short for Application Performance Monitoring. People use the term observability, which is something that APM also does. Really, you should kind of think of APM as a combination of metrics that basically kind of describe what your system did, observability, which is understanding how it did it, and then logging, which kind of falls in the middle of those two somewhere. So APM vendors all have their own sort of bespoke clients, SDKs, and agents. And the way people have instrumented their applications for a long time is installing all these different components that belong to different vendors they might use. So if you're a Datadog customer, you might install a Datadog agent on all of your virtual machines, maybe a Datadog client inside your applications, and so on. Well, this was sort of not sustainable for a lot of reasons. The biggest one being that it basically made it impossible for library authors to really reliably expose their metrics and their activities in any way that would allow them to be consistently observed and traced and recorded across this huge spectrum of different vendors. So the next approach people use to try to go ahead and unify all these different grammars for, let's say, metrics in particular, was developers would try to go ahead and build some wrappers that would take a common set of, let's say, here's a counter, here's a gauge, here's a histogram. These are different metric types you might use to describe your application's runtime behavior. And we're going to go ahead and try to build a common grammar around it and program against all these SDKs and give you kind of a common library you can use to target them. That's what the app.metrics project did successfully in .NET for so many years, but this comes with its own problems, which is to say that even with a project as well maintained as app.metrics, you're still going to get lots of idiosyncrasies and differences between vendors and different configuration options, and you're going to have lots of byte rot because the APIs that app.metrics talk to might be evolved at different rates, and it's a hard problem. So finally, the next step that people came up with to try to solve this APM consistency problem in kind of a systematic way was to develop some open standards. So for instance, I've done a couple videos about open tracing before. That's an open standard for describing distributed tracing between applications. And that defines some common terms such as what's a span, what's a context, how do we go ahead and define the relationships between those spans. And then there was also the OpenCensus project from Google, which in addition to covering distributed tracing, also introduced metrics into the equation. And so this is kind of what the state of the APM ecosystem has looked like over the past several years, up until a couple of years ago when OpenTelemetry was first introduced. And OpenTelemetry, as of a couple of days ago, has now reached its 1.0 sort of stable specification, so it's ready for production use going forward now. Now, the problems we had with the old ways of doing stuff was that first, it was very difficult to migrate between application performance monitoring solutions. So you basically had vendor lock-in is the issue that you really had here. Next is that the performance overhead of APM varied quite wildly between implementations. Back in like 2012, 13, 14, I was running a very large scale .NET Framework application on top of AWS Elastic Beanstalk. That's kind of their platform as a service option that's built on top of EC2. And we installed New Relic into those machines, and it absolutely jammed up the processing of incoming HTTP requests to an unacceptable degree. So we had to end up winding it back and making some calls directly to the New Relic SDK in a couple areas rather than letting their agent auto-instrument it. This was a really common issue where switching from one APM vendor to another became a very big devil you know versus devil you don't type problem. And lastly, I spend most of my time maintaining Akka.NET and a couple of other shared libraries that a lot of .NET users depend upon. And it's very difficult without a common standard to target to come up with a way to expose internal events and metrics so they can be traced or monitored. It's very difficult to do that Typically what most libraries depended on were things like event hooks to go ahead and do those sorts of things. But it was very hackneyed, and it was mostly the responsibility of the user to put all that together. So the problem that OpenTelemetry solves for all of us is that it took the two competing standards, so OpenCensus and OpenTracing, and combined it into a unified standard that has the buy-in of all the major APM vendors. So Stackdriver, Datadog, Dynatrace, Elastic, even open source projects like Jaeger and Prometheus and Zipkin are all targeting OpenTelemetry as kind of the new lingua franca of the APM ecosystem going forward. So this solves the problems that I just had on the previous slide quite well. In particular, one of the really big differences, and I believe this was borrowed from OpenCensus's approach, is that all traces and metrics are produced by the OpenTelemetry library itself, meaning that the instrumentation that gets injected into your application actually isn't produced by any of these individual vendors anymore. Rather, the open source library that OpenTelemetry is built around is what actually creates your traces and metrics that you produce. When I say you produce, this can also mean like the libraries that you're built on top of produce them as well. I'll go ahead and talk about how these are all exposed in a moment. But long story short, all this data gets produced by a core OpenTelemetry library. So you don't have this vendor lock-in problem that we had before. The OpenTelemetry library exists regardless of which APM solution you use for creating alerts, doing aggregation, doing monitoring, actually visualizing all of your data. That is now no longer relevant. Essentially, the gathering data about how your application is performing versus turning it into useful information. APM vendors are basically being cut out of that first part, the actual gathering of information. That's the responsibility of OpenTelemetry. It's the responsibility of the APM vendors that you use, whether they're a PaaS solution like Datadog or a self-hosted open source solution like Prometheus. Their job is to take that data, persist it, and then correlate it all together into some sort of usable experience that you and your team can use to understand how your system performed and why it performed the way it did. So this also means that we get consistent performance now. My APM sort of footprint on a really busy Akadana application is going to be the same if whether I'm using, let's say, a Prometheus plus Jaeger exporter versus a Datadog exporter for both metrics and traces, because the actual production of those metrics and traces are still handled by the same library. The only thing that's different is how we actually export the data. That's where we're going to get to in a little bit, but that's where the vendors like Datadog kind of enter the picture again, is the export pipeline for OpenTelemetry and OpenTelemetry metrics and traces and logs. The other thing that the OpenTelemetry standard does is it gives us as library and framework authors the ability to target something directly in our code. So rather than having to force the user to glue everything together, now we can go ahead and produce traces and metrics that can be surfaced via the OpenTelemetry pipeline without needing to worry about what other components are running inside our customers' applications. So for instance, if an Akadana actor makes a call to an entity framework context to perform a query against SQL Server, the trace that was created when the actor started processing that message will automatically be correlated to the SQL query that actor ran. You'll see that show up inside a platform like Jaeger, which is one of the ones we'll be looking at in our demo. So this really solves that problem of what library authors need to do to be able to make it easy for their users to understand what the library did when this particular operation was running through it. Makes it much easier to go ahead and expose and surface that now in a consistent way that's less work for the user. Next, the OpenTelemetry library provides a consistent grammar for metrics, traces, and logs. So for instance, counters and gauges and histograms all mean the same thing across every APM platform now. Whereas in earlier, let's say, implementations, those might vary slightly, and those slight differences could actually make a really big impact on how you do things like define alerts, for instance. So if you want to migrate from using, let's say, Datadog to New Relic, your old alerts may not end up being measured the same way due to these small idiosyncrasies between the platforms. That's no longer an issue because the OpenTelemetry standard is consistent, and it's the responsibility of the vendors to go ahead and support them properly. Lastly, the OpenTelemetry implementation, like I mentioned earlier, it's vendor neutral. We have what's called an export pipeline built into it. And you can export to multiple vendors simultaneously if you want. So for instance, if you have to export to both Dynatrace and Splunk, you're able to go ahead and do that quite easily now. The export pipeline makes that very easy to do for metrics, traces, and logs. So this is what the OpenTelemetry tracing infrastructure looks like. I'm able to go ahead and let's say I'm building an ASP.NET Core application that uses Entity Framework and the HTTP client and some Akka.NET actors, for instance. If I go ahead and get a request through, let's say, Razor Pages in ASP.NET Core, ASP.NET Core will automatically go ahead and create a new trace for that. If that request results in me sending an HTTP request to another service via the HTTP client, that will create a span, which is a logical operation that is one part of a trace. And that span will be correlated to the same span that was created by ASP.NET Core. So automatically, all these different little activity sources are able to be correlated together as a result of how OpenTelemetry flows context throughout your application. It uses an async local, essentially, to go ahead and flow context throughout your app. Each time you go ahead and do an await, the trace that was there in the previous context will flow down to it. And we can go ahead and kind of stitch all these operations together. And I'll show you a diagram of what that looks like in just a moment. All of the traces that are produced by these activity sources, which are built into these libraries, all get handed over to the tracing pipeline here. And that'll get processed by one or more processors. So a processor can do things like sampling. You can go ahead and sample traces in order to make sure you don't run up a huge bill with, let's say, Datadog. Or you might use a processor to filter out certain types of traces you don't want. So for instance, if we end up generating a whole bunch of SQL Server health check queries, maybe we don't want those to go ahead and appear inside Jaeger or Datadog because they're just taking up space and they don't tell us anything interesting. We can go ahead and write a custom processor to filter those out. And we can look for those traces based on the operation name. So if we see like a stored procedure that shows up over and over again in our SQL command namespace, we can go ahead and just filter any of those traces from that data source with that name out and not export them to Datadog. Then finally, we have our exporter. This is where data goes from being inside your application to being exported to some destination. That's usually going to be a cloud-hosted APM vendor or a self-hosted one of those two. The metrics pipeline works exactly the same way with one small difference, which is that because metrics aren't correlated in the same way that traces are, so for instance, we don't need to go ahead and keep track of, if I have a latency metric inside ASP.NET Core, that has no bearing on a throughput metric from Akka.NET, for instance. Those two metrics could be affected as a result of, let's say, a common bottleneck, but that's something you would find in your tracing. What the metrics are just designed to do is to tell you how your application is performing, not why it's performing the way it is. That's the job of the tracing system. So metrics are really there for being able to build dashboards, alerts, and data visualization kind of around how your application is performing at runtime. And its pipeline for how it exports metrics is identical, more or less, to how the tracing pipeline works. It also supports processors for being able to perform sampling and other types of post-processing activities. And then it also supports a pluggable exporting pipeline where we can export metrics to multiple destinations if we want. Now, as for why OpenTelemetry is going to be significant in .NET in particular going forward, one of the reasons why is because Microsoft has blessed OpenTelemetry as the official telemetry solution for all .NET base class libraries and all of Microsoft's frameworks. So this includes things like ASP.NET, Entity Framework, the HTTP client, and probably a bunch of other frameworks I'm forgetting. But OpenTelemetry is now the standard. And it's backwards compatible all the way back to .NET Standard 2.0. So this means that any .NET application built against .NET Framework 4.6.1 or later will be able to use OpenTelemetry. You just need to install some NuGet packages in order to do that. The built-in namespaces that OpenTelemetry uses are part of the system.diagnostics.activity and system.diagnostics.metrics namespaces. So these are base class libraries that you might have to install as separate NuGet packages if you're running on an older version of .NET. If you're running on .NET 6 or .NET 7, these should be built in, I believe. And these are where essentially the core components of OpenTelemetry and .NET come from. Now, there's also an OpenTelemetry NuGet package that wraps both of these inside a OpenTelemetry compliant API. The reason why we have these sort of two differing implementations is Microsoft basically needed a control surface that they had at both hands on the steering wheel on in order for these to be surfaceable via the base class libraries in .NET. That's what the system.diagnostics namespace is for. The OpenTelemetry NuGet package simply wraps those and exposes it using the same semantic conventions the rest of OpenTelemetry has. OpenTelemetry, by the way, I guess one thing I have not mentioned yet so far is also it works cross-platform. So if you send a distributed trace between, let's say, a .NET service and a Node.js service, and both of them are using OpenTelemetry, you should be able to go ahead and trace that service call between those services, and they will both show up inside the same chart in Datadog, even though the implementations are different. That's one of the other reasons why OpenTelemetry is so impactful, is it's an open standard that is bigger than .NET. It encompasses pretty much every major backend language is all supported with it. Lastly, the OpenTelemetry library is very high performance. I mean, it's designed to be used inside Microsoft services such as Bing. So they have to go ahead and reduce allocations. They have to come up with efficient ways of pre-aggregating metrics together. And they need to go ahead and make sure that this doesn't have a, let's say, untoward performance impact on the large-scale services that Microsoft itself runs. So we're going to be the beneficiaries of that as .NET developers, and we can go ahead and use those same high-performance characteristics to make sure we don't have any problems in our own applications that we're developing as well. So before we dive into a code sample and show you how to actually instrument OpenTelemetry inside your .NET applications, let's explore some of the OpenTelemetry concepts first, because these are going to be what you actually produce as a result of installing OpenTelemetry. So the first major concept is OpenTelemetry tracing. This is probably the most complex part of OpenTelemetry because it involves propagating context between multiple services. We've talked about distributed tracing multiple times on our YouTube channel, and that's what OpenTelemetry tracing is in essence. So we have one logical operation that begins a request, and that's this HTTP GET at the very beginning here. So ASP.NET, if it's instrumented using one of the OpenTelemetry NuGet packages, will begin creating root spans for traces that had no context originally. So if a browser goes and opens your home page, like how we're doing here, and generates a brand new request, this will create what's called a root span in OpenTelemetry. So that root span represents the beginning of one logical end-to-end request. Every operation that is kicked off as a result of that will be connected to it via the tracing context. And the tracing context in OpenTelemetry is propagated via an async local in .NET. So every time you do an await, the context that existed before will be propagated down to the new child context. Every time you create a new root span, a new active span, we're going to tie that active span back to the previous parent one, and you'll see all these operations be correlated together inside your OpenTelemetry compliant backend, which could be Datadog or Jaeger in this case. So we start with an HTTP GET. We use that to create an ask in Akka.NET. That ask produces a message that an actor is going to process. And in the course of that actor trying to process that message, it might execute a SQL query using Entity Framework. All of these different operations will be correlated back together and will be framed into a histogram that looks like this, where you can see kind of the end-to-end request time for the original HTTP GET is going to be the sum of all the parts beneath it. And if there's multiple operations running concurrently as a result of that HTTP GET operation here, you'll can see a couple of different child histograms appear below it in whatever your preferred tracing platform is. Some of the key terms to bear in mind, on the left, I have the system.diagnostics.activity name for this. On the right, I have the OpenTelemetry name for this. So we have an activity source. This is a source of tracing activity, and it's normal to have many of these per application. Each instrumentation library for OpenTelemetry, whether it's ASP.NET or Akka.NET or the HTTP client or entity framework, each one will have its own activity source, and that'll produce events that can be traced together. An activity represents an individual logical unit of work recorded during a trace. All of those spans we saw on the previous graph are all examples of activities. So they're all logical operations. Every time you do an await, you're probably going to produce a new activity. That's kind of the general workflow there, although you don't have to do it that way, but that's essentially what I would consider to be the convention around that. Next, we have the activity context. This context gets propagated between service boundaries in the form of HTTP headers. There's a W3C standard for propagating context that way, and that's what your web browser and what frameworks like ASP.NET Core and the HTTP client will all use. If you're using a system like RabbitMQ or Kafka, you might have to go and manually inject and extract that header information into the metadata on each of your messages. And if you're using Akka.NET, libraries like Phobos will automatically propagate that context behind the scenes using some serialization data in order to do that. Next, there's attributes. Attributes are searchable properties of a span. We're going to be using Jaeger here in a moment, and you can actually go ahead and search for various attribute values. So a good example, if you're processing a request for a specific customer in your, let's say, customer-facing web application, you might want to search by customer ID to try to figure out what happened to all of those customers' requests. And then each individual span can also have multiple events appended to it. So for instance, in ASP.NET, you might want to go ahead and take every single event produced via the iLogging interface and go ahead and append that to your trace. In fact, I believe that's done for you automatically. In Phobos and Akka.NET, we go ahead and do that for the Akka.NET iLogging adapter, and we also go ahead and add events for things like when the message is queued into the mailbox and when the message is finally dequeued for processing by the actor. So those events essentially produce a little time frame within each span if there's multiple events that occur there. Next, we have the OpenTelemetry metrics. And the most important member of this namespace is the meter, which is the activity source equivalent for metrics in OpenTelemetry. So every library that you instrument will have its own meter. So ASP.NET will have one, the HTTP client will have one, Akka.NET will have one with Phobos. And these meters typically bind a number of counters, gauges, and histograms to them. These are the different types of devices you can go ahead and use to measure how your application performs. They're planning on adding a couple of additional counter and gauge types to OpenTelemetry metrics over time, but these are the mainstays that are in the platform right now. You'll go ahead and construct, and you'll see this in the code sample we're about to pull up in a moment. For most of my applications, I tend to use counters for 80% of all my metrics. I'll occasionally use gauges for some things. A good example, if I want to go ahead and measure things like the number of threads that are active in a process at any given time, I'll create an observable gauge that'll periodically pull the thread count for the process I think it will do that every 5 seconds roughly. And then I'll use histograms for measuring distributions. So a good example is measuring things like latency distributions. Histograms are perfect for doing that. So with all that said, we're going to move on now to taking a look at a little demo. All right, so this is my simple ASP.NET OpenTelemetry demo. We're going to use OpenTelemetry metrics and tracing here. So if you follow the README instructions, it'll explain how to launch Jaeger, which is the distributed tracing system we're going to use for visualizing activity inside of our app. I already have that up and running here on this tab, and I have my web app itself running here. And if we want to see the metrics coming from OpenTelemetry, I'm going to go ahead and open a new tab, and we'll just go to metrics. And you can see in Prometheus format all of the data being collected here. So these are, I believe this is a histogram that's keeping track of the latency and the distribution of status codes for each of the different HTTP routes we're recording. And then down here we have a custom counter that I've programmed into our app, and we can go ahead and see the metrics coming from that as well. So let's go ahead and take a look at the source code itself inside the sample. Okay, let me shut this down real quickly. Okay, so this is an ASP.NET 6 minimal application. Let me go ahead and open our CS project so far. We've installed the following NuGet packages. So first is the OpenTelemetry.api package. You actually probably don't need to install this one directly if you're installing any of the exporter or instrumentation packages, because this is a dependency of all of those. So we're installing this. This is where all the core OpenTelemetry libraries come from. I'm installing the exporter for Jaeger, the exporter for Prometheus. This is the little metrics format we're looking at earlier. And then this is a really important package, OpenTelemetry.extensions.hosting. This is what provides all the extension methods for being able to configure OpenTelemetry inside your application. And then we're adding these instrumentation packages here, one for ASP.NET, one for HTTP, and one for the SQL client. These are basically little libraries that hook into the event lifecycles for ASP.NET, SQL client, HTTP, and we're going to go ahead and expose a activity source and a meter for each of these libraries here. So that's what these are all for. If we go to program.cs, we're going to use a minimal configuration. We're going to go ahead and start by creating a resource builder. A resource is going to be what describes the instance of the service we're using, the service name, and the version of that service. So this is called demo.asp.net. And this resource is going to be passed into our OpenTelemetry tracing here and our meter. So if I go to Jaeger real briefly and I hit refresh, you'll see that the demo.asp.net service has showed up. And when I click Find Traces, you'll see that all the traces that are in here are all requests that originated with the demo.asp.net service. So the resource is used to identify within the topology of all the different services that make up your applications, each individual unit of work, so each individual service, each instance of that service, and the service version, and also possibly its namespace. You can trace requests between multiple different services. If you click into one of these traces, you would see, let's say if I demo.asp.net and demo.backend service, you would see a boundary between these services appear right here. And because of the way trace is propagated in HTTP headers or in Akka.NET messages or inside manual headers you'd use in the service like RabbitMQ, you can go ahead and actually stitch together these transactions that cross service boundaries. That's what distributed tracing is all about in the first place. This is the resource component of our OpenTelemetry configuration. If I go back to our app, let's take a look at the rest of the builder. So these are the extension methods introduced by the OpenTelemetry.extensions.hosting NuGet package. And we're going to add this little OpenTelemetry tracing builder here. We're going to add a Jaeger exporter. This is going to be by default exporting to the default UDP endpoint that the Jaeger agent uses. Our Docker container that we're running in the sample is already running there, so we don't need to specify any defaults. However, if you're running a production application, you might need to use the little builder here to go ahead and configure exactly where you want to send that data. We're going to add a source right here. This is a way of subscribing to an activity source inside our application. If I look at our telemetry constants file right here, I have a static read-only field that has my custom activity source in it, and I have one that has my custom meter as well. So if I go and create an activity source or a meter and they start producing events, none of that data actually gets exported unless I manually subscribe to it inside my configuration for OpenTelemetry tracing and metrics. And that's what I'm doing right here with this little constant value. We're going to use the extension methods that are exposed by all of the instrumentation libraries. So one for the HTTP client, one for ASP.NET Core, and one for the SQL client. These are basically going to call behind the scenes an add source method for each of these different libraries. So they're going to have some statically defined source name. In fact, if we take a look at our Jaeger trace here and look at this trace, which was produced by, here we go, OpenTelemetry.instrumentation.asp.NET Core. So that's the name of that activity source that we're subscribed to. Whereas our manual activity source that I created is just called demo.asp.net. So that's where all that information is coming from inside our app here. And then for metrics, our export pipeline looks nearly identical. There's no SQL client instrumentation for metrics at the moment, but we do have HTTP client and ASP.NET Core metrics as well. And then one last thing you have to do for Prometheus, because the way Prometheus works is rather than pushing metrics to an APM system, the APM system gets configured to scrape an HTTP endpoint on each of your services to gather those metrics. That's actually a lot more performant at scale than trying to push a huge number of metric events over the wire is. So we have to go ahead and add a little bit of routing to our ASP.NET app here just to support that Prometheus scraping endpoint. So that's all the configuration we need to actually build our tracing and metrics pipelines in OpenTelemetry. Let's take a look at some actual instrumentation code I wrote myself. So this is a code behind on my Razor page. I'm having the tracer provider passed in as a dependency injected argument. This is just so I can use the OpenTelemetry.apis, which I actually prefer over system.diagnostics.activity. I'm used to using Open Tracing, which is the standard that came before OpenTelemetry, so this is a lot more similar to that, whereas the system.diagnostics.activity API is a little clunky, in my opinion. So what I'm going to do is create first a tag list. A tag list is a zero allocation data structure for applying tags to your metrics. Tags are basically a set of dimensions you can aggregate metrics by in your APM platform. So in this case, I'm going to go ahead and aggregate metrics based on my user agent. I could also aggregate metrics based on things like if I could geolocate the customer's IP address to a specific country, I could say, okay, customers from the United Kingdom are in this bucket, customers from Germany are in this bucket, customers from Canada are in that bucket. And that would allow me to do things like query latency by country if I wanted to, which could help me identify maybe an upstream problem like an issue with my CDN potentially for some of these customers. And then down here, I have my tracer. So all spans that you use for trying to track local activity inside your application, all of those are disposable. And so when you start the span, this begins the time tracking where we measure how long the operation lasted. And you can always append additional attributes to the span, such as I'm going to include the trace identifier inside the span. So this is going to be the unique HTTP trace ID generated by the browser. So if I want to go and follow any requests that were generated using this trace identifier, I can actually use this property and go searching for it inside Jaeger. In fact, you can see that tag show up right down here. This is the unique identity of my trace that was generated by the browser. And in fact, this is probably already baked into the identity of this trace operation itself, since these two are correlated. This is what the basic OpenTelemetry tracing API looks like. I can also go ahead and add an additional event to this trace, this received HTTP request from blah, blah, blah.user agent. And if I take a look at the logs down here, you can go ahead and see that right down inside my Jaeger output here. So this is what the OpenTelemetry APIs actually look like. They're actually quite simple in practice. I always recommend using tag lists, by the way, when you get a chance to. That'll help reduce the amount of allocations you need to record metrics. Tag lists can support up to 8 different dimensions, and I wouldn't recommend going above that. You're going to start running into billing problems on a platform like Datadog if you start having a gigantic explosion of dimensions that you're aggregating metrics on, so you want to keep that in mind. And then in the tracing system, we also have a similar concept of tags known as attributes, which are the way in which you can add searchable properties. And you can actually create a collection of what's called initial attributes that get passed into every span you create. So that might include data that belongs to the instance of the process rather than data that's specific to the request. So the APIs for OpenTelemetry are very flexible for both tracing and metrics. And it's a really great technology to get experienced with now because it's going to become more and more commonplace throughout not just the .NET ecosystem, but really every software development ecosystem. So if you want to get more OpenTelemetry tips and hear a little bit more about it, I'd recommend subscribing to our channel. Otherwise, thank you very much for your time. And if you found this video helpful, please leave a comment below. Thank you very much.